Hi folks, welcome to this Cancha tutorial on how to import block models that have been rotated. Rotation of block models is something that happens when the deposits got sort of long and thin structures, and the resource geologist decides that, if they were to put a regularized grid on there, which doesn't line up exactly, it could lead to excessive dilution, because you can see here that there's some blocks that are only just touching the vein, so they'll be given quite a low grade, when in fact, we don't want to lose this material. So it's just not convenient for mine planning. It gives the impression of low grade. So what they do is they rotate the block model to line up with the structures. Consequently, you get more blocks with more in each one. The average grade is better, and as a consequence, the project looks more attractive. So that's what it's all about. But what happens when we try to import a block model into Cancha? And if we try to import it without realizing it need to be rotated, what you can see happens here, that you've got it on an angle there, you've got all these blocks, but the way Cancha guesses the block size, it guessed that there were very small blocks, because it's in the north, south, east, west planes, there's very little gaps between the blocks, so it puts a minimum block size on there. And it doesn't really understand how to organize this. As we see here, we go to the top view looking down and zoom right in, we can see that these dots are on an angle, and the blocks are very small, and there's a lot of gaps between them. This absolutely kills Cancha performance. Even on a powerful computer, this will run like a dog, because it's imported many millions of blocks, because they're all very small 1 meter blocks. And then on the 3D rendering visualization part, it's very slow, because it's got to render all the surfaces of every block because of the gaps between them. So the same block model, ideally, we'd want it to, look something more like this. That if we've got this clipping plane on there, we can see a nice clean clipping plane. We can see all these values. And if we try to project this onto metallurgical samples, the metallurgical samples will all be properly populated with the information from the block model, because there'll be coincidence between them. But if we go back to the unrotated one and do a clipping plane or a section, you'll notice that there's really nothing coinciding at all. Just because the blocks are so small, there's an awful lot of blank there. So on the drill logs and on the met samples, you'll have a whole bunch of stuff that just doesn't have any values. So that's the reason why it's super important that you detect this during the importation process. So let's go ahead and import a file. And that's the easiest way to show. Just go ahead and import it. Add this rotated block model CSV file. And it's been detected correctly as a block model. Here is the file type. Hit next. And here we can get a clue for that something's a bit off, because we can see the easting and northings have all got kind of strange decimal places for the location. That's usually a sign of either a subcell block model or a rotated block model. In the case of the RL, they're all nice 0 decimals and stuff like that, so it makes a lot better sense. So because I think this is rotated, I'm going to go ahead and click on the advanced block model controls. Here we've got this tool where we can see in 3D that clearly on the on this axis here, they're all lined up, and on this axis here, they're all lined up, so no problems there. But if we look at it from above, it's been rotated. So we're looking down the RL axis, and you can see that it's got this rotation versus the RL versus the coordinates on the plane perpendicular to the RL axis. So we need to rotate around the RL, eyeballing it. Like normally, you should talk to the resource geologist or whoever's documented the block model. There should be a legend file comes with a block model, and in there it should say what the rotation is and which axis to rotate around. But you can guess it too. So I can just maybe 30 degrees. Is it 30? Looks a bit too much. Try 26. Oh, it's getting better. You can see it's almost there, but it's not quite there. The block size got bigger. That is detecting, and there's still a few gaps. Let's try 25. And boom, there it is. So you can see all the dots are nicely lined up on the Cartesian grid. And The blocks are all nicely formed at 20 by 20 by 18. These are normal numbers that people should be expecting from a block model, not crazy decimals. So, and if we look at it in 3D, we can see that there's exactly one dot inside each block. So this is looking way better. This is good to go. Okay, so we're good with a 25-degree rotation around the vertical axis, and that's going to give us a 20 by 20 by 18 block size. So just hit apply to that. We can see those parameters there. Everything else is good to go. Hit next. Now, if you're importing it and it was unrotated and it was meant to be rotated, it can sometimes take like an hour to import. You know, it can be terrible even on a good machine. You'll notice that if we click on here, it'll tell us here what the rotation angle was on the data that's been imported. And now if we look at it in 3D, we've got a good looking block model that we can use. Okay, so that's rotation of block models and importing them into Cancha. Thank you.